Hello everybody, can you hear me? Okay, so today I'm going to talk about owning the network, owning the corporate network, owning the DMZ by taking over a database server. Any database server, not only SQL Server, not only Windows, can be anyone. I am a proud father, first of all. I work as pen tester for Portcalis Computer Security, a UK-based information security company, and by the way, we are also hiring. If you are interested, just come speak to me. I'm an open source enthusiast. I've been developing a few tools. They are all released under GPL license. And today I'm going to demonstrate SQL Map new features. Introduction. Database management system, as I said, are very powerful applications. Their most important task is to store and interact with data, store it in a proper way and interact it efficiently. But these, all the modern databases actually support integration with file system. And if they don't support integration or with the file system or the operating system, you can force them to do, you can tweak them to do, you can abuse other functionalities to make them do what you want. If you cannot force them, you can exploit them. So, scenario, let's say that you are in front of a database management system. So, it's a database server. Either way, you are connected to a database, being it direct connection because you have been provided with accounts, so it's like a gray box testing, or you have brute forced the accounts, or you are connected through a database via SQL injection, so you found that you spotted a SQL injection in any web application, standalone client, cache machine, any application that uses a database backend to store and interact with data. So what to do now? You can enumerate data, okay, alright, that's fine, but if you want more, you want to touch, you don't want only to touch the surface. If you are a pen tester, you want to see and prove to the client that this single vulnerability, either SQL injection or weak passwords or buffer overflow in the database server itself, can allow you to own the entire underlying operating system or even other servers within the network. So, what is the state of art so far? Last year I've been presenting few techniques, many others have been presented as well in the past. About SQL Server and Oracle, there is nothing new. Many people have done good researches in the years about command execution and privilege escalation by abusing SQL Server and Oracle. These are just a few ones, few examples. What I've been done last year is I focus mostly on MySQL, and Postgres. These are two open source database softwares. Actually, what I did was just, well, let's see if I can reproduce what XPSMD shell or any other storage procedure or PL SQL functions in Oracle can do. So how do I execute commands? Well, actually I inject a user-defined function. What is a user-defined function? It's just your code, your C code, that you compile as a shared library by using the database management system development libraries. You compile it, as I said, as a shared object, you upload it, and then you create your own functions out of it. I create a couple of functions that I will show just in a bit. Postgres, on top of this, supports also procedural languages, so you can execute Perl, Python, TCL, TK code on top of directly from the database instance. But as far as I know, all the pre-built-in the bundles to install Postgres, both for Windows, Linux, and other operating systems, don't enable these procedural languages by default, so they are useless in an environment that uses pre-built packages. So I created, as I said, a few user-defined functions, and actually both for MySQL and Postgres. This is one very simple one, sys_eval. Actually, when you call this function, you call it in a select statement, so select sys_eval, and as argument you pass it a command. That command will be executed on the underlying operating system. Nothing very fancy, just reproduction and porting the concept behind XPCMD shell SQL Server procedure on other DBMS softwares. So owning, as I said, owning the database server is not only about operating system command execution. You can establish an out-of-bound connection which doesn't use the same channel to inference data to take over the other boxes on the net. Alberto is illustrated, for example, his own tool, DNS, which performs a spoof DNS tunnel, Heyoka, over UDP, or you can use TCP as a stream. Over this TCP stateful connection, you can have, for example, any Metasploit payload, Meterpreter, shell, BNC, execute command, download software, any other. Take a picture from the webcam, whatever. So let's make it more stealthier, because in a real environment, attackers make things in a way that they are not easy to, it's not easy to track them in a forensic investigation. So what can you do? You can forge a shell code with MSF payload, then encode it with MSF encode to bypass a few or several antivirus products, depends on the encoder that you use. Then you use MSF CLI locally, so which is the Metasploit command line interface, by listening on a predefined TCP port or performing a connection to the database, depending if the shell code is a bind connection or a reverse connection. So if the database allows outgoing connection to arbitrary TCP ports, you lose a reverse connection. If it has some ports that are not filtered by the firewall, so some ports that from your port scan are not filtered but are closed, you can abuse this misconfiguration of the firewall to bind your shellcode on that specific unfiltered port. Then on the database server, you create a UDF that executes the payload in memory. So you don't call anymore sys_eval, because actually sys_eval only execute one single command. You simply want to, in this case, you want to execute arbitrary opcode encoded in alphanumeric, because you are calling it from a select statement, either from a SQL injection point of view or from a direct connection to the database. So as I said, this is an anti-forensic technique because it's hard to track in a forensic investigation because actually the payload itself is not stored on the file system. It doesn't touch the surface of the file system. It's directly executed in memory with privileges of the user running the instance of the database software. So I created a new user-defined function. I called it sys_bin_eval. It's quite self-explainable. I will go into quite a lot of details how this works and what protection mechanisms it bypasses. Actually, it can cope very well in Windows systems that have data execution privation and XBit enabled, either software that or hardware that, because since I inject my own C code, I create and I allocate with virtual alloc on Windows or mmap on Unix. I allocate the memory already, that memory page where I will put the shellcode on, the Metasploit shellcode on and execute it. I allocate it as executable already. So there is nothing that can bypass in this case because the developer itself already will execute. The attacker itself will execute its shellcode on a memory page that is marked, is created, is allocated as executable. So actually, sys_bin_eval, as I said, support alphanumeric payloads only. Why? Because the problem when you are exploiting any vulnerability, or most of the memory corruption vulnerabilities, is that you have to prepend the get_pc function call to your shellcode to be able to locate itself in memory. But if you encode it as an alphanumeric encoded, these bytes are not alphanumeric. These are binary data. So if you are attacking the database through a SQL injection, it's hard and the vulnerable parameter is a get parameter, or even a cookie in some instances, or even a post in some instances. It might not support binary binary strings. So how I solve this problem? MSF encode is cool enough to support an undocumented option called advanced option called buffer register. And so basically when you encode your shellcode, you pipe your MSF payload to MSF encode it with the alphanumeric encoder. You also specify that you want your workflow to be redirected at the time that the payload is called to the memory address stored into the EAX register. So this is great, but how can you put your own payload on the memory address referenced by EAX? Well, you have actually control of your C code. The UDF that you have created on the database server is created with your own code. So if you append to your to the function that will call the payload this little snippet of assembly code, actually what it does here, actually it specifies that the payload must be moved, the payload address, LP payload or whatever, has to be moved to the memory address to EAX register, and then you call with a call or a jump instruction directly into that memory area, and so it's executed. So far we've solved two problems. You don't need binary data to inject any opcode, meterpreter, BNC, whatever. First. Second, you bypass memory protections like the EP, stackward on Unix systems, or NX-bit if it's hardware. This said, the third thing that this user-defined function copes with is the fact that it avoids the BMS crashes. In a production environment, if you exploit a database server, you don't want it to crash. Otherwise, it will be a pain for you with the client to explain why it crashes. So what I do is I spawn the whole process of injecting the payload and executed it in an executable memory location into a thread. And this thread itself is called within a structure exception handler (SEH) frame with a try code. So even in the worst case scenario, if the payload crashes, it will then rise an SEH exception, which will be handled by the structure exception handler object in Windows. And it will kill the thread. So the worst case is that your shellcode will not end up, not close properly, in a proper way after the execution. So this is the worst case scenario. So this is a code snippet of the user-defined function. As you can see, it's perfectly pure C code with some references to MySQL development libraries and Postgres development libraries. I've created it, I've compiled it, it's open source, it's part of SQLmap. SQLmap automates for you all the process of injecting it and executing it. It works either on Windows or Linux. I made it recently work also with compiled with Visual Studio 2008, where assembly cannot be merged into the same code, but you have to call it in a separate file, and works on both 32 and 64-bit architecture. And this is an interesting thing. So, let's see an example. Or maybe let's see two more slides, and then I'll make an example to make things more clear. So, am I really unprivileged? Well, as I said, your code, either xpcmd shell, syseval, or sys_bin_eval, like any other operation, any other query, is executed with the operating system user privileges of the user, which is running the database software instance, the database process. So, until Microsoft SQL Server 2000, usually it was running a system. Then from SQL Server 2005, by default during the installation, you can select which is the operating system user to be used to execute this database instance, but by default it goes with network service or local service. So I'm privileged user and virtual user. On Postgres and MySQL, they both run as a very unprivileged user on any Unix environment. Interestingly, MySQL on Windows run as system always, whereas Postgres also on Windows run as an unprivileged Postgres user. The name is Postgres by default. Well, regardless of the OS operating system user running the database process, the attacker can escalate privileges. How? Well, there are many ways to escalate privileges. Now we are in a post-exploitation scenario. We've got access to the database either via SQL injection or direct connection. We can execute commands, as I just said, via different techniques, regardless of the database that you are exploiting. SQL map implement them all. Now you want to escalate privileges. So once you are system, once you are root, once you are tour on the box, well, the surface and the amount of things that you can do and theoretically compromise is much wider. So the point is, be creative. There are many techniques out there. Some have been widely documented. And recently, since a couple of months, the Metasploit guys, Stephen Fewer in particular, has implemented a very powerful command in the Meterpreter, which is get system. This abuses, when you call it, it tries 4 different techniques to get system privileges. These include as well Kitropod, which is a kernel flow unpatched for about 17 years, since Windows NT 3.5 up to Windows 7, recently patched by Microsoft in February this year. You can abuse weak permissions on file services, named pipe LSA design, like incognito, pass the hash, or others. You can abuse, at this point, memory corruption bugs in third-party libraries, in third-party software, in the operating system, default software. You can abuse the all user startup file trick, which is a trick that you write a file in the startup folder for all users, and you have to wait that an admin logs in, and this script will be executed. You can make it that it creates a user like an administrative local user, and then you log in with that user. But this requires time, because you have to wait that an administrator log in or re-log in. So at this point, what do? Well, who am I is your friend, tells you who you are on that box. So let's see if we can make it work. So I will make a quick demo. I'll make it larger. Yeah, I'll go SQL map, specifying the U option to say where I think the SQL injection is. In this case, it's in a test environment. This is the test environment. It's a Windows 2003 Service Pack 2, running an instance of SQL Server with the default unprivileged network service user, and running an instance of Postgres, which spawns different processes by design. We're running as Postgres unprivileged user. So I have a web server, IIS, with different ASP and ISPX pages here. They are vulnerable to SQL injection, but this is not the topic of this talk. I will specify minus v2 to say SQL map to be verbose in the details that we print on standard output, and then OSPwn to specify that I want to own the operating system, and union use just as a mere way to exfiltrate the data, to get the data out. And then I have to specify the path where MSF, where Metasploit is installed, and then privesc, because by default it won't privilege escalate. By specifying this parameter, it will escalate. SQL map automatically detects for you the SQL injection. It checks for you if it's affected by a Boolean-based, time-based, and/or union query SQL injection. So it identified that it is affected by a union query SQL injection. And what else it did? Well, it checks if the current user is DBA. Doesn't make a lot of difference, but in this case it is. Then it checks if my two user function are created. If they are already present in the database, it doesn't recreate them, so it saves time. In this case, they are not created, so it will just abuse one Postgres functionality to remotely upload a binary file, because the DLL, the shared library, is compiled, so it's a binary file, but it's base64 encoded, so totally fine with either text and binary vectors, like get or post HTTP requests. Then it will abuse, as I said, the low_export Postgres built-in default function to create the DLL out of that uploaded hexadecimal base64 encoded string. At this point, it will create the two user-defined functions, sysbin_eval as sysexec out of the just uploaded DLL. And then it will ask me which way I want to use to execute the Metasploit shell. Either via sysbin_eval or by uploading a payload stager, so writing it on the file system as a exe, as a portable executable, and then execute it. Of course, I want to go with the default technique, which is in-memory way anti-forensic. It asked me options to generate the Metasploit shellcode. I will go with the default ones. Then it shows me which is the command that it calls. As you see, it encodes it as alphanumeric here. Takes some time because Metasploit itself takes a bit of time to load all of its modules. Should be done in a few. It creates locally and then it runs, as I said, Metasploit command line interface locally, so it will listen on a predefined port. This is the TCP port that my box, the attacker box, will be listening on. And this is done by Metasploit again. Metasploit is wrapped into SQLmap, but could be any other tool. Okay. So, what it did? Well, it was loading, and then it binged on my box, this box here, on this port, MSF command line interface, and then on the other side, so on the other side, on the database server, it exploited the SQL injection to call the injected user-defined function by passing it an alphanumeric encoded string. In this case, it's not only alphanumeric encoded, but it's also encoded with CHR, which is the Postgres conversion, numeric conversion function to numerically convert each character. So it's totally ASCII compliant character. And here we go. We have a Meterpreter session. It's established. It's an out-of-bound connection. Doesn't use HTTP anymore. It loads by default automatically for you all or the most useful Meterpreter extensions. It shows you that the server username, the OS user running the Postgres instance is Postgres. Then it calls for you automatically because you specified --priv as when you call SQLmap. It shows you that it got system. If it didn't get system with this technique, it would use the token passing technique, the incognito technique, automatically. And then now, here we go. We are system, and each command I run works. Well, I could just use the root command to specify subnets, different subnets, to route the traffic from my attacker box to the internal network, to the DMZ, to any other network within the network perimeter of this own box. So, from a web application, from a vulnerability in a web application detected by the tool, up to system on the box. And either way, either if you are connecting through a SQL injection or not, SQLmap automates it all for you. Going back to the slides, well, yeah, I've got luck in this case. If I wouldn't have had luck to get administrative privileges on the box, I would then try different other tricks to be able to escalate privileges. So, what more? Well, we've got to the point that we exploited the database software and we are able to communicate with the internal network, so we can exfiltrate data, take over other boxes, route our traffic. So in practice, pivot our traffic through the own database server. So what more can be achieved? Well, you can, as I said, inject your own user-defined function. You can execute on the database server any C code, C or ASP code that you want, whatever, regardless of what it does or it doesn't. And to make things easier, you write your code with the database management system development libraries. You compile it as a shared object yourself with GCC if it's Unix or others compilers under Windows, or you cross-compile it. And then you fire up SQL map with this little switch, UDF inject, and then the tool will ask you a few questions about which are the user-defined functions created in this shared object, how you want to call them, which parameters they return. And then, at this point, the tool will abuse a technique to upload the file, the binary file, which is the one containing your user-defined functions. It works for SQL Server, MySQL, and Postgres, regardless of the version of the database software and the architecture of the underlying operating system, and then it will execute them onto the database server at your request. So, what else? As I said, regardless of the technique that you use to connect to the database, being it SQL injection or direct connection, so you speak the database server protocol. There are many Python libraries to do that, and other languages as well, of course. You can take over the database. Well, from mid-2006 up to March 2010, SQL Map is being called and referenced as yet another SQL injection tool, that's true, with some kick-ass features like buffer overflow exploitation via SQL injection, sys_beneval, file system access, either read or write file access, as I demonstrated. It can be text file or binary file. Any architecture, any operating system, doesn't really matter. It abuses other database-specific design flows. All in all, it is a one-shot favorite script kiddie tool, as some cool friends of mine call it. So now it's not only a SQL injection tool with some cool features, it's the only tool, free tool as far as I know, that is able to take over a database server as a whole, that can either use web applications, so SQL injection, and or direct connection to connect to the database. I'll make a quick demonstration out of it. Well, let's close this Meterpreter session. Yeah, SQL Map also drop for you automatically the function just to not leave traces that you touched and you own the database server if you want. In this screen here, I want to use the -d flag, which is the new one, to connect directly to this SQL server by specifying in it the credentials, SA, which is the administrative default username, and testpass, which is a test password that I use for SA on this box. As I said, it's running as network service. Then I specify this is the SQL Map specific syntax, and then -v3 because I want to have verbose output, and then I use the OS-BOF flag, which exploits a specific SQL Server buffer overflow, MS09004, to denote SQL Map was the first and only tool to have this exploit reliable, quite reliable, on Windows against Windows 2003 running with dep enabled.
and it is a NIP overflow vulnerability in a specific storage procedure, quite hard to exploit actually. Later on, other open source and commercial frameworks have implemented this exploit. As far as I know, one commercial framework has its own exploit for this vulnerability that bypasses that, the other doesn't. And Metasploit as well has recently implemented their own exploit, which is quite reliable as well. So, as I said, it connected to the database, fingerprints it for you, it tells you that it's going to exploit this memory corruption vulnerability. So again, it asks you how you want to forge the Metasploit shellcode, which in this case will be injected and executed within the payload that triggers the buffer overflow vulnerability. Let's go with the default options. It's fine. In this case, I also ask which is the payload encoder to use. I will go with the one that is less detected by antivirus products. It created it. It was very quick this time. And then, this is the function. This is the whole code that exploit this buffer overflow, first. And second, as you can see, there are no single quotes, no double quotes, so it can theoretically bypass limited IDS and IPS. As you can see, it sends the second stage, because I did it a Meterpreter session in a multi-stage exploit, because I wanted to have a very small payload to fit within the area that I can overflow. Again, it runs at network service, this process. It abuses Tetrapod vulnerability, and now we are a system. We just exploited the buffer overflow through direct connection in this case. And as you can see, I have an interpreter session. I can run any script or anything. From here, I can hash dumps. So I've got the sum hashes. So these are the password, the LM passwords for all the operating system users. I can also abuse these passwords to own other machines. How? I will see that right now. Next second slide. So, but wasn't it mean to wrap it up, to sum it up, conclusions? Wasn't it mean to deal with data? It's database. Well, you've got access to a database management system. Once you've got that access, either, again, via web application, via standalone clients with SQL injection vulnerabilities, cache machine, any vector that you use to access a database, to exploit a database, you have good chances to own the underlying operating system and from them escalate privileges. How? By abusing kernel flows with permissions, mostly on named pipes and services. Usually third-party services have weak permission that you can abuse, and they run a system. So once you are able to manipulate the service, the Windows service, well, you can execute your own code, and your own code will create an administrative or a domain administrative, or even worse, an enterprise domain administrative user. So when you have a high-privileged OS user, local user, you can dump the hashes and crack them, or you can spray them around directly. It's possible, by design of SMB protocol, to use the LM or NTLM version 2 hash to connect directly over NetBIOS, NS, or MSN SMB port 445. I wrote a tool to do that, which is Kimvix, and you can freely download it. So the next step would be just to upload it through Meterpreter. Meterpreter is the command upload, or use SQL map write file flag, write file functionality to upload that file. Either way works. It's a Python script, but you can use Py2x to create a portable executable out of it. So it's one file, you upload it, and then you call this tool by passing it the output of hashdump, which is this one,
or any other output containing clear text password and user containing the output of MS cache. Any tool that can dump hashes is properly parsed and recognized. You pass it also a list of hosts, a list of domains, and it will try all the hashes and clear text passwords against all of those boxes that you specified. So you know exactly in one shot how many boxes you can route in one click over SMB, over Meterpreter session. So, questions? Thanks for your attention.